Hello everyone. So today we will still be doing some problems on projectile motion. These are the three questions that we will be doing, the questions that are appearing on the screen. So let us just solve them one by one. Question 1, question 2, question 3. So let us start with question 1. A particle is projected with velocity 2 root over ag so that it just clears two walls of equal height A, which are at a distance 2a from each other, show that the latest rectum of the path is equal to 2a and that the time of passing between the walls is 2 root over a by g. So if you see the question, okay, we are going to need the formula for the latest rectum. Okay, the formula is below. And also what we will be doing is we will be needing the path of the projectile. Okay, as you will see why. Okay, so let us just try to solve this question. Okay, I will minimize this one. Okay, so let's try. So if you are taking a look at the question, what we are having is that we are throwing a projectile and there are two walls of equal height. Okay, just let me draw it properly. The two walls are of equal height. Okay, the height of each wall is A. So this is a wall and this is also a wall. Both of them are of equal height A. And the distance between the two walls is 2A. You are given that the velocity U, the velocity of projection U, is equal to 2 root over AG. If you are seeing the question, just let us check. 2 root over AG. So we need to find the latest rectum as well as the time of passing between the two walls. So let's see. Solution, it will start like this. So over here, actually, even though it's not given, we will require the path of a projectile. Why do we need the path of projectile? Because over here, if we can denote this position of this one by x1 from the origin, if this is the origin, the distance of this first wall is x1 and the distance of the second wall is x2. So we can have that x2 minus x1 is equal to 2a. And over here, so the coordinates of this point, it will be x1. The height, it is still a. The position of this wall, it is x2. The height, it is still a. So over here, we are having coordinates. Once you have coordinates, you will ultimately be using the equation of the projectile. So that is where we will start. And also, if you take a look at the second part of the question, you are required to find the time of passage between the two walls. Okay, so the time taken from P to Q. Okay, P. Okay, so we need to find the time taken for the projectile to travel from P to Q also. Okay, so let's see. Let alpha be the angle of projection. U is the velocity of projection, it is equal to 2ag. So it's best if we square it in advance. So you will be having 4ag. U square will be 4ag. Okay, so this is what is given to us. So because we also need the time, so what I can write, let t1 be the time taken from O to P. And t2 be the time taken from O to Q. Okay, we are measuring the time from O to P and O to Q. So the time from P to Q, it will be T2 minus T1. That is clear. Okay, so let's see. Then what can we have over here? So x1. If you remember, the first equation of motion says, the second equation of motion says that S equal ut plus half at squared. But x1, it is the horizontal velocity. So x1 is the horizontal distance. So we will be using the horizontal velocity as well. The acceleration due to gravity in the horizontal direction will be 0. So instead of S, I am putting x1. Instead of u, it will be u cos alpha. T1 instead of t plus half at squared. The acceleration, it is 0. g in the horizontal direction it's 0. So that is why we will be having this. Also x2, it will be the same because x2 it is the horizontal direction, so it will be t2, but we require the time from p to q, so that is why we will subtract these two equations. Therefore x2 minus x1 equal u cos alpha t2 minus t1. If you denote t to be the time from p to q, t time taken from p to q, so t2 minus t1 it will be equal to t, and if you are taking a look at this figure, x2 minus x1 will be 2a u cos alpha, so t. So just keep this one as equation 3. Okay, we will need this one, so let us hope that we remember them. So I will write it over here because we will need this equation again ultimately. So if you take a look at this equation, what do we need to find? Okay, so we want, if you are taking a look at the question, the time taken from p to q, it should be 2 root over a by g. So there is no longer this alpha, so we have to get rid of this cos alpha somehow. Okay, so keep that in mind. Okay, we will try to get rid of this cos alpha either by finding the angle or simply by substituting in the value of cos alpha in terms of a and g. Let us hope that we can do that. Okay, so this is all that we can proceed from here. Now what will we do? I will write now. Now the part of the projectile is y equal x tan alpha minus gx squared by 2u squared cos squared alpha. How did I get that one? It is by the equation below, the equation of the part projectile. So over here you are noticing that the y coordinate for both of the points, they are the same. What differs is only in the x coordinate. So this is what we will do because we are having two different values for x. I won't be substituting x over here. I will be substituting only the y coordinate. So this is how I will do it. Y, it will be a x tan alpha. Okay, let us write that one. Minus gx squared. 2u squared, it will be 8ag cos squared alpha. 2u squared will be 8ag cos squared alpha. So this is what we got. Now what will I do? So over here we are substituting the value of y, which is the same, and if you are noticing this equation, because we are throwing at an angle, so the angle is also fixed. Everything is fixed except x. So this one will ultimately be a quadratic equation in x. Okay, because x is the only variable over here. So what can we do? We can solve for x. So we will be finding x1 and x2. So this is what we will do. So just multiply. You will be having 8a squared g cos squared alpha. 8 multiply this one here. You will be having 8ag sine alpha cos alpha x minus gx squared. So let us bring all terms to over here. So you will be having gx squared minus 8ag sine alpha cos alpha x plus 8a squared g cos square alpha. So this is what we are having. It's equal to 0. So because everything is a constant except x, so that's why there will be a quadratic equation in x. A quadratic equation in x. Okay, so because it is a quadratic equation, it will give us two roots, x1 and x2. How do I know that it will be these two roots? Because we have substituted the value for the y coordinate, which is a. So it will give us two roots, x1 and x2. Okay, we don't need this figure anymore. So let x1 and x2 be the two roots. So if you are taking a look at the picture, if you remember, x2 minus x1 is equal to 2a. Okay, u square equal 4ag. Let's keep that also, maybe we'll need it. If you are taking a look at the picture, we are having x2 minus x1 is equal to 2a. So from over here, what we can do, we can find out the value of x by using the quadratic formula, or we can do something even better. So you must remember that sum of the roots, it will be minus b by a. Okay, minus b by a. Okay, maybe I'll write it minus b by a, which is a quadratic equation in x, similar to ax squared plus bx plus c equal to 0. So the sum of the roots, it will be minus b by a. Product of the roots, it will be equal to capital C over a. So sum of the roots, it will be x1 plus x2 minus b by a, so it will be 8g sine alpha cos alpha. So this is what we are having, and product of the roots is equal to c. This one is c, and a is equal to g, so we will be having x1 x2, it will be equal to 8a square g cos square alpha. Sorry, we don't need this g anymore. Okay, so it will be equal to c by a. So this is what we get. Now what we can do is we can write something like this. We know how much is x2 minus x1. Now x2 minus x1, we know how much the value is, but we will be squaring it. Why are we squaring it? Because we can write x2 minus x1 whole thing square in terms of this one and in terms of this one. We can write it like this, minus 4x1 x2. Alright, if you are checking this one, it will be equal to the right hand side. So that is why this equation, we can use it. So x2 minus x1 whole thing square, x2 minus x1, it's 2a whole thing square. So this one we will be having 64 x1 plus x2, I think it is 8a. From over here, yes, it is 8a. So sorry, I made a mistake. So x1 plus 8 x2 whole thing square will be 64a square sine square alpha cos square alpha minus 4x1 x2 will be 32 a square cos square alpha. So this is what we are having. Now 2a whole thing square will be 4a square. Okay, the same thing. Now what we will do is, okay, we can cancel a square, and then 4, over here we will be having 16, and over here we will be having 8. So 1, it will be equal to 16. Now we can also convert sine into cos. We can write it in this way. Because if you remember what I said in the very beginning, we need the value for cos alpha. So that's why we are writing it like this. 8 cos square alpha. Okay, so over here will be 16 cos square alpha minus 16 cos power 4 alpha minus 8 cos square alpha. So if you transfer everything to this side, you will be having 16 cos power 4 alpha minus 8 cos square alpha. This and this one will give you plus 8. If you transfer to this side, will be minus 8 plus 1 equal to 0. So again, this one we can write it as 4 cos square alpha minus 1 whole thing square. This whole thing can be written like this. Okay, a minus b whole thing square will give you the above, so we can write it like this. So this, okay, we can do it. Now over here we can just write 4 cos square alpha minus 1 will be equal to 0. So cos square alpha equal 1 by 4. So cos alpha equal 1 by 2. Okay, the negative sign is rejected because if you remember, the angle alpha, it was in the first quadrant, right? So cos alpha will be positive. Negative is rejected since alpha is in the first quadrant. So we have got the value of cos alpha. So now we can just substitute it over there. Okay, hence what we can say, that this one was equation 3. Hence equation 3 gives 2a equal u. It is equal to 2 root aj. Cos alpha is equal to 1 by 2 t. So this is what we are having. 2 and 2 will get cancelled. So 2 t, it will be equal to 2a by root aj, which you can write as 2 root over a by g. Okay, so this is how we got the time. The time of passing between the two walls, it's equal to 2 root over a by g. Again, if you are seeing the question, we also need to find the latest rectum. The latest rectum, we can use the formula below. Latest rectum, it will be equal to 2 u square cos square alpha upon g. So 2 u square will be 4ag. Cos square alpha will be 1 by 4 upon g. So you will be having 2a. Alright, so just take a look at the question. I think that is indeed what we want to find. Okay, if you are saying the latest rectum is 2a and the time of passing between the walls is 2 root a by g. Okay, so this is how we do it. Again, it is a very simple exercise. We just need to remember that we have to use the equation of the path projectile. We set the y coordinate and then we use the sum of the roots and product of the roots. That is all you need to remember for this exercise number 1. Okay, so now let us do exercise number 2. Okay, exercise number 2 also it's similar. Over here in exercise number 2, what we are having is that now it's given that you are throwing a projectile. Okay, you are throwing projectile. The height of the two walls, it's h. So again, it's similar. But what is given over here is that the walls are situated at horizontal distance a and 2a. Okay, so the walls are of equal height. Okay, maybe here. Both of them have the same height h. So over here, the distance of the first wall, it is a, and the horizontal of the second wall, it is 2a. x2 is equal to 2a, x1 equal to a. So this is what we are having. So we just need to find the velocity. Okay, so what we will do, that u be the velocity projection and let alpha be the angle of projection. Okay, so let's try to do it. Okay, so what we can do over here is that we can directly use the equation of the path projectile. Okay, why don't we use anything that involves the time? Because the question, if you take a look at the difference between question 1 and question 2, question 1 involves the time, whereas question 2 does not involve the time. So that's why we will go straight ahead with the equation of path projectile. Okay, so now equation of path of projectile. Equation of the path is y equal x tan alpha minus g x square 2u square cos square alpha. So again, because they are of the same height but only differs in horizontal distances, we will substitute y equal h. The rest we will leave it as it is. Okay, x tan alpha gx squared 2u squared cos squared alpha. So now we can multiply this one over here as well. 2u squared cos squared alpha h equal 2u squared cos squared alpha. Tan alpha you can write the sign by cos. So we'll be having sin alpha cos alpha x minus gx squared. Again, take this one to this side. Okay, take everything to this side. You will be having gx squared minus 2u squared sin alpha cos alpha x plus 2u squared cos squared alpha h equal to 0. So this is what we are having. So again, which is a quadratic equation of the form, ax squared plus bx plus c equal to 0. Okay, so it is of this form. Okay, so again, it is a quadratic equation. So again, we can use the sum of the roots and product of the roots. So let's see. Okay, what will we have? So now we can write the sum of the roots equal minus b upon a, and product of the roots is equal to capital C upon a. x1 plus x2. If you are noticing, x1 was a, x2 was equal to 2a. So x1 plus x2 will be 3a. Minus b upon a. So this one is b. So you will be having 2u squared sin alpha cos alpha upon j. Sin alpha cos alpha upon j. x1 x2. x1 it was equal to a and x2 was equal to 2a. So x1 x2 will give you 2a squared. C upon a will give you 2u squared cos squared alpha h upon g. So this is what we are having. So now what we can do, it's very simple. So we just need to find the velocity u. So what we can do is we can square this one, because over here you are having cos squared alpha. So we can square this one. If you are squaring, you will be having 4u power 4 sin squared alpha cos squared alpha upon g squared. So this is what we are having. And also remember this. Sometimes if you are having sine and cos, it is best that if you square them, because while squaring you can maybe hope to use this important identity as well. Maybe we will try to use this at some point of time. So over here 2 and 2 will get cancelled. So you will be having a squared equal u squared cos squared alpha h upon g. So we can write down u squared cos squared alpha equal ga squared upon h. So if you substitute what we have over here in this equation, 4, we can leave it as it is. So u squared, sin squared alpha, we can leave it as it is. But also we will be having u squared cos squared alpha upon g squared. We can calculate this one separately like this. 4 u squared sin squared alpha. U squared cos squared alpha will give you ga squared upon h. So g and g squared will get cancelled. You will be having this. A squared and a squared will also get cancelled. So 9, it will be equal to 4 u squared sin squared alpha upon gh. But if you take a look at the question again, question number 2, you are saying that we don't need any alpha. Alpha should not appear in the expression, in the final expression. So that's why we will convert this one into cos. Okay, so let's see how will we do it. 9 equal 4 u square sine squared alpha, you can write it as 1 minus cos squared alpha upon GH 4u squared minus 4u squared cos squared alpha. Okay, so now we just have to simplify it. Okay, 4 GA squared upon H upon GH. Okay, by using this one again, u squared cos squared alpha. Okay, so 9GH equal 4u squared minus 4GA squared upon H. So this is what we are having. And if you remember, we need to find the velocity. So for u squared, you will be having 9GH plus 4GA squared upon H. So now let us just see what do we need to express it as. Okay, G by H. G by H we have to take common. Okay, we will take common G over H. Let's see. G by 4 we need to take common. Okay. Alright, so this is how we will write it. Okay, 4u square. Okay, then u square will be 9 upon 4gh plus ga square upon h, divide whole thing by 4. So now we just need to rewrite the expression u square. We can take common g by 4. If we take common g by 4, over here you will be left with 9h plus 4a square upon h. So this is what we are having. Okay, let us see whether this is the required expression or not. Okay, so this is the required expression. So this solves question number 2. Okay, as you can see, these questions are fairly easy once you know the technique. Okay, so now let us solve question number 3. Question number 3 is also no different. We just have to use the equation to part of the projectile. Okay, so what happens is in question number 3 is that you are having projectile. It passes through 2 points P, whose coordinate is x1, y1, and another point may be Q, whose coordinates is x2, y2. We are having that the alpha is the angle of projection. Okay, and u is the initial velocity. Okay, so let's see. Okay, what can we do? Okay, so the equation over here, if you are noticing, x1 it's different, x2 is different. Again, the height, y1 and y2, they are different. Okay, so we cannot just substitute only one. We have to substitute both these coordinates if we want to find something. Okay, we cannot just substitute only the y coordinate like what we did in question 1 and question 2 because they are of different heights. Okay, they may be of different heights. That is why substituting only the y coordinate may not help us. Okay, solution. Equation of part is y equal x tan alpha gx square 2u square cos square alpha. So if you are noticing the question, again we will need the formula for the range, which is given by the formula above. So let me just write it over here. R, it is 2u square sine alpha cos alpha upon g. Okay, because we will need r also in the expression. Okay, so let's see. If you are noticing at this expression, just take a look. If you are noticing the expression, we need to show that tan alpha equal y1 by x1. Okay, we need to show this. Tan alpha equal y1 by x1 times r by r minus x1. Okay, so we need to show this one. If you are noticing over here, you need this term y1 by x1. So you will first divide this one by x. So you'll be having y by x equal tan alpha. Divide the whole thing by x. So you'll be having this. Now what you can do, you can transfer this one, okay, just simplify it. 2u square sine alpha cos alpha minus gx upon 2u square cos square alpha. So this is what we are having. Okay, but we need to bring in r in this equation. So what can we do? Okay, we need to bring r into this equation. So that is why we can see that 2u square sine alpha cos alpha will be gr. Okay, so this one is equal to gr minus gx. Now this one, what we can do, again we need the value for r. Okay, so we can multiply and divide by sine, because in r we also have sine. 2u square cos square alpha sine alpha sine alpha. Okay, so this is what we will do. Again, we are bringing sine over here because the formula for r involves sine. So this is what we are doing. Y by x. So over here we can write it as g r minus x. And over here we are having 2u square sine alpha cos alpha. And then we will be left with cos and sine. Cos by sine will give you con. So if you bring it onwards, it will be tan alpha. So this is what we are having. Again, this g, you can write it below. Or you can write it like this. 2u square sine alpha cos alpha again will be equal to gr. So you'll be having this one. Hence, you will be having r minus x upon r tan alpha. That is why tan alpha you can write it as y by x times r by r minus x. So this one we have not substitute any value, okay, y and x, but we can ultimately do this. Okay, so if it passes through x1 y1, we can tan alpha y1 by x1 r by r minus x1. So this solves the first part of the question. Okay, so the first part of the question is very easy. So now let us just do the second part. Show that if it also passes through x2 y2, then tan alpha equal that expression over there. Okay, so what we can do is it also passes through x2 y2. Okay, so this one we can name it as equation 1. If it also passes through x2 y2, so we will be having the same thing. Instead of y1 we will be having y2 r minus x2. So name this one as equation 2. Okay, the angle remains same alpha because it is the same projectile that you are throwing at the same angle. So nothing will change. So now what we can do is, okay, I want to keep these two equations. Okay, so maybe I will just write them to the sides. Okay, so this one is the first equation, r minus x1. So this one is equation 1. Okay, I'm just rewriting it because I know that I will need them again. This one is equation 2. So because the left hand sides are equal, so the right hand sides will also be equal. From 1 and 2, you will be having y1 by x1, r by r minus x1 equal y2 by x2 times r by r minus x2. R and R will get cancelled. So this is what we have. So now what we can do, so we can write it as y1 x2 upon r minus x1 equal y2 x1 by r minus x2. Okay, so now we can multiply them. So we'll be having y1 x2 r minus y1 x2 square equal y2 x1 r minus x1 square y2. So this is what we are having. So you can find out that r, okay, take this one to this side, you will be having, okay, x2 square, take this one to this side, take this one over here, so you'll be having x2 square y1 minus x1 square y2 divided by, okay, x2 y1 minus x1 y2. So this is what we are having. Okay, name this one as equation 3. Okay, so this is what we are having. But if you are taking a look at the question, okay, we need a different expression. Okay, we need tan alpha, but also the numerator, it should be x2 square y1, which we have got. So the numerator, we no longer have to change r. Okay, we will hope to get rid of this one somehow, but we need to change the denominator of equation 3. Okay, so we need to change the denominator of equation 3. Okay, somehow we will be hoping that it will work out at the end. Okay, so this is how we will do it. If you are noticing, the denominator contains x2y1. Okay, so we will need to have x2y1 somewhere. Okay, we can multiply equation 1 by x2. Multiplying equation 1 by x2 and equation 2 and this equation 2 by x1, because you will need x1 y2. Okay, we can, okay, x2 tan alpha, x1, okay, we need x2 y1, upon x1 r minus x1. So this is what we are having. Okay, equation 3 also I will keep it. Okay, so I will not erase this one. And also multiplying equation 2 by x1. So I will write it over here. x1 tan alpha equal x1 y2 upon x2 r by r minus x2. Okay, so this is what we are having. But if you are not saying, we need x2 y1 minus x1 y2. Okay, so what can we do? Okay, so we can eventually transfer this one to this side. Okay, into r minus x1 equal r x2 y1. So similarly, this side we will be having x1 x2 tan alpha equal to into r minus x2 equal x1 y2 r. Okay, so what we can do now, okay, we can divide this one by this one. Okay, let us see what we will be getting. This one make it as equation 4. This one make it as equation 5. Equation 4 divided by equation 5. Also, sorry, we will be needing x2 y1 minus x1 y2. Okay, so we can just subtract them. equation 5, equation 4 minus equation 5 will give us equation 4 minus equation 5. Okay, so we'll be having x1, x2 tan alpha, we can take common, r minus x1 minus r minus x2. So this is what we are having on the left hand side, and the right hand side will be r x2 y1 minus x1 y2. So this is what we are having. Tan alpha. Okay, so this one we will be having x2 minus x1, x2 y1 minus x1 y2. Okay, so now what will we do? Okay, we can substitute this value, okay, in equation 3. Okay, substituting this value in equation 3, we will get equation 3, if you remember, it was r, the numerator was x2 square y1 minus x1 square y2, and the denominator it was this one, so you will be having x1 x2 tan alpha x2 minus x1 upon r. So this is what we are having. So just transfer the things that you need over here. So r and r will get cancelled. You will be having over here 1. So tan alpha carried to this side. So you will be having the required expression. x2 minus x1. So this is the required expression, okay, which solves question number 3. Okay, so the questions are fairly easy. It's just that they are sometimes a bit lengthy. Until next time.